Hey everyone, and welcome back to another Prep to Perfection Grade 12 Maths class. Just a quick reminder, if you boost your marks, you stand a chance to win 5,000 Rand. How amazing. Simply click the link down below to enter the competition. I'll now hand you over to your tutor, Camilla.
In this video, we're going to start with Euclidean geometry, and we're going to look at ratio, proportions, and similar polygons. The objective for today's lesson is to understand ratios and proportions in geometric context, identify necessary and sufficient conditions for polygon similarity, apply ratio proportions to solve geometric problems. To begin, we ask ourselves, what is a ratio? A ratio describes the relationship between two quantities of the same kind, written A or A over B or A to B. Ratios have no units and should be simplified. Example, if a rectangle has a length of 20 centimeters and a width of 80 centimeters, then the length is 20 to 60 or 1 to 3. The properties of a ratio. A ratio gives no indication of actual size. The same ratio can apply to different sized objects. So 50 centimeters to 150 centimeters is 1 to 3, whereas 0.8 meters to 2.4 meters is exactly the same as 1.3. Ratios should be kept in a fractional form, not converted into a decimal form. Proportions. We can look at A to B and B to C. This would give us x over y. And then we can look at DE, which is kx, and EF, which is ky. And this will give us kx over ky. And these two will be proportional to each other. Proportion. The line segments AB and BC are in the same proportion as DE and EF. The following statements are true. Proportions AB over BC is equal to DE over FE. The reciprocal proportions BC over AB is equal to FE over DE. And then cross multiplication. AB times FE equals BC times DE. We can also substitute x, y, kx, and ky to show that algebraically that the statements are true. For example, BC times DF equals y times kx plus ky equals ky, open brackets, x plus y. And AC times EF equals, open brackets, x plus y, close brackets, times ky equals ky, open brackets, x plus y. Therefore, BC times DF is equal to AC times EF. Given the parallelogram ABCD, if AB is 3 to 2, area is equal to 120 centimeters squared, find the dimensions of the parallelogram. So we're going to let AB equal 3K and BC equal 2K. Then we're going to use the area formula to work out the dimensions. So we know that area for this type of parallelogram is base times height. But instead of base, we're going to use AB because we're given it here. So we're going to say that area is equal to AB times height, and this will equal 3K times height, which we know that our area is 120 because it's given here. So this equals 120. So I'm just going to rewrite this here. So 120 is our area, our base is 3K, and then just our height. So now we can divide both sides by 3K. And this will give us 40 over K, and this will give us H. From the properties of a parallelogram, we can determine that AB is equal to 3K, which equals 3 times 4, which equals 12 centimeters. Then for BC is equal to 2K, which is equal to 2 times 4, which equals 8 centimeters. Then for the height, h is equal to, and we know that k is 4, so 40 divided by 4 equals 10 centimeters.
Alright everyone, that's it for today. But don't forget to keep practicing so that you stand a chance to win 5,000 Rand. Click the link down below to enter the competition and we'll see you in the next class.